Right, this is Unit 9, Lesson 3, Ellipses. Our lesson essential question is, how does the equation of an ellipse relate to the features of its graph? At the end of this lesson, you'll be able to describe the features of an ellipse given its equation or graph. All right, so concept. This has a lot of vocabulary words in it, okay? So features of an ellipse. An ellipse is the set of points P in a plane such that the sum of the distances from P to two fixed points, f sub 1 and f sub 2, is a constant. The fixed points are the foci, or with one, it's just focus, okay? So if I look at, here's my ellipse, here's my focal point 1, and my fixed point 2. So here's my foci, and here's my point P. Okay, so if I add these two together, they're going to give me a constant K. The major axis is the segment passing through the foci with endpoints on the ellipse. So here's my vertex and my major axis. The endpoints of the major axis are called the vertices. Singular is vertex of the ellipse. So here is my vertex and my vertex. Okay? The minor axis is the segment perpendicular to the major axis at the center with endpoints on the ellipse. The endpoints of the minor axis are called the co-vertices or co-vertex of the ellipse. The center of an ellipse is the midpoint of the major or minor axis. Okay? So here, again, here's my ellipse. Any point on this circle, I pick two foci. And if I add them together, they give me a constant, okay? From there, I can draw a line, which is my major axis between those two foci, and it ends at a vertex on either side of the ellipse. Going through the center, that's my co-vertex and my minor axis. Example 1, derive the equation of an ellipse.
The graph of the ellipse passes through the points 0, 5 and 0, -5 and has foci at 0, -4 and 0, 4. Write the equation of the ellipse. Notice that the point 0, 5 lies on the ellipse and that it is 1 unit from the focus, 0, 4. Point 0, 5 is 9 units from the focus, 0, -4. The sum of those distances from the point 0, 5 to each focus is 10. The definition of an ellipse states that the sum of the distances from the foci to any point x, y on the ellipse must be a constant, in this case 10. Use this fact and the distance formula to write an equation. The distance formula gives the distance between 2 points. We can use it to find the distance between a point x, y and the first focus, and add it to the distance between x, y, and the second focus. You know that the sum of these distances for the ellipse is 10. One focus is 0, -4, so substitute those coordinates into the equation. The other focus is 0, 4. Simplify the equation. To simplify, move one square root to each side of the equation. Square both sides. This removes the square root from the left side. Then expand all binomials in the equation. Next, isolate the remaining radical. Then collect like terms to simplify. Divide both sides by 20 to finish isolating the radical. Square both sides to remove the last radical and simplify. Notice that this equation looks similar to that of a circle. If we complete one more step to make the constant term 41, the equation contains certain features evident in the ellipse. The standard form of the equation of an ellipse centered at the origin is x squared divided by b squared plus y squared divided by a squared equals 1 when the major axis is vertical, and x squared divided by a squared plus y squared divided by b squared equals 1 when the major axis is horizontal. The square root of 9 is 3, so the length of the minor axis is 2 times 3, or 6. The square root of 25 is 5, so the length of the major axis is 2 times 5, or 10.
All right, what is the equation of the ellipse in standard form, which has foci at -2, 0, and 2, 0, and for which the sum of the distance for the foci is any point on the ellipse is 8? So the last time we were given two y coordinates, these are on x coordinates, which means that our major axis is going to be horizontal as opposed to vertical. So last time we were dealing with a horizontal or a vertical, and then this time we're dealing with a horizontal as our major axis. So I know that I can use these 2 points and the distance formula and set it equal to 8 in order to solve for my points. So I get the square root of x minus -2, which is a +2 squared, plus y minus 0 squared, plus the square root of x minus 2 squared, plus y minus 0 squared, and that equals 8. I'm going to go ahead and simplify. So x plus 2 squared plus y squared plus the square root of x minus 2 squared plus y squared equals 8. I'm going to move the second equation here to the other side, or the second square root to the other side. And then I'm going to square both sides. This gives me x minus 2 squared plus y squared equals 64 minus 16 square root of x minus 2 squared plus y squared plus x minus 2 squared plus y squared. Okay, I'm going to go ahead and factor out all the binomials. So I get x squared minus 4x plus 4 plus y squared equals 64 minus 16 square roots. X minus 2 squared plus y squared plus x squared 4x plus 4 plus y squared. I'm going to go ahead and move everything except the square root. I'm isolating the square root for both sides of my equation. So I get x squared minus 4x plus 4 plus y squared minus 64 minus x squared plus 4x minus 4 y squared minus -16 square root x minus 2 squared plus y squared. Right. Then I'm going to go ahead and combine like terms. The x squared and the negative x squared goes away. 4x plus 4x is 8x. 4 and -4 cancel. Y squared minus y squared cancels. And so I'm left with a -64 equals -16. Square root of x minus 2 squared plus y squared. Okay, I'm going to divide both sides by -16, so that's 8 divided by -16 minus 64 divided by -16. And that's going to equal the square root of x minus 2 squared plus y squared. So that gives me 8. -16 gives me -1/2. X. And then plus 4 equals the square root of x minus 2 squared plus y squared. I'm going to square both sides. So that gives me -1/2 times -1/2 is positive 1/4 x. Minus 2x minus 2x, so minus 4x. X, and then 4 times 4 is 16 plus 16. Equals x minus 2 squared plus y squared. Okay. And then I'm going to move everything to the other side. So I have 1/4 x minus 4x plus 16 equals x squared minus 4x plus 4 plus y squared. Okay, so that gives me 1/4 x minus 4x plus 4x minus 4x minus x squared plus 4x minus 4 stays there, minus y squared equals 4 minus 16. Okay. So 1/4 minus x squared, so 1/4 minus 1 is -3/4. So -3/4 x, -4x and 4x cancel each other out, minus y squared equals -12. Okay. I'm going to go ahead and multiply by -1, so that gives me 3/4 x plus y squared. Oops, this should be an x squared. What's my x? Squared. 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 Okay, y squared equals 12. Okay, now in order to get it to look like my equation, I need to divide everything by 12. So I need to do 3/4 divided by 12. Oopsie. 4 12. X squared plus y squared divided by 12 equals 12 divided by 12. So this gives me 3/4 divided by 12 gives me x squared divided by 16. Ah, it keeps doing this. X squared divided by 16 plus y squared divided by 12 equals 1. All right, example 2, graph an ellipse. Graph the ellipse that has the equation x squared divided by 45 plus y squared divided by 36 equals 1. What are the coordinates of the foci? So major axis, the major axis is determined by the variable component of the fraction with the largest denominator. So in this case, the 45 is the largest denominator. So that's what I'm dealing with, my major axis. From this ellipse, the major axis is horizontal. Remember that you have those two. So if it's vertical, then this would be your minor. But if this one's larger over the x squared, it's going to be a horizontal. Okay, so for this ellipse, the major axis is horizontal based on the general equation a squared equals 45 and b squared equals 36. So a equals 3 square root of 5 and b equals 6. Since the ellipse is centered at the origin, the vertices are -3 square root of 5, 0 and 3 square root of 5, 0. That's my vertices. So the minor axis, remember, I'm dealing with this 36. The minor axis is vertical, so the co-vertices are 0, 6, and 0, -6. The foci, to find the foci, let C represent the distance from the foci to the center. The Pythagorean theorem shows that the distance from 0b to each focus is the square root of b squared plus c squared by the definition of an ellipse. The sum of those distances, 2 times the square root of b squared plus c squared, will be the same as the sum of the distances from a0 to the foci a minus c and a minus -c or a plus c. Set the sums equal to each other. So 2 times the square root of b squared plus c squared equals a minus c plus a minus -c. When I simplify that, I get 2 times the square root of b squared plus c squared equals 2a. Square root of b squared c squared equals a. So b squared plus c squared equals a squared. To find the foci in this ellipse, I solve for c. I know that b is 36 and a is 45. So I have or 6 squared plus a was 3 square root of 5 squared, which is 45. So 45 minus 36 is 9. Square root of 9 is 3. So the coordinates of the foci are negative 3, 0, and 3, 0. Okay. So knowing this, I can use this equation, this b squared plus c squared equals a squared, to find my foci. You can check using technology, solve the equation x squared over 45 plus y squared over 36 equals 1 for y to check the graph. Using technology, y equals plus or minus 6 square root of 1 minus x squared over 45. All right, let's try it. Graph the ellipse represented by the equation, then find the coordinates of the foci. So x squared over 64 plus y squared over 100 equals 1. So I have 64 and 100. I know that 64, the square root of 64 equals 8, and the square root of 100 equals 10. So that gives me my 2 points, or my 4 points. So the 10, this tells me it's a vertical. So I'm going to have 0, 0, 10, and negative 10. Okay, and then my other points are at 8, 0, and negative 8, 0. So here's my ellipse. And then my foci, so 10 is a squared. So 10 is a, b is 8. So if I have b squared plus c squared equals a squared, well, b is 8 squared plus c squared equals 10 squared. So that's 64 plus c squared equals 100. So 100 minus 64 is 36. C squared equals 36. So the square root. C equals 6. So that means my foci are at 0, 6, and 0, negative 6. So 2, 4, 6. Yep, they're right there. So you can see them. All right. Next, I have x squared over 16 plus y squared over 8 equals 1. Drag the points in to set the axis of the ellipse. So I'm given 16 and 8. So I'm going to take the square root of both of those. So 16, the square root is 4. For the square root of 8, it's 2 square root. Or approximately 2.8. Okay. So my larger one comes first, so it's a horizontal. So my points are going to be at 4, 0, and negative 4, 0. So 4, 0, negative 4, 0. And then my minor axis has values of 0, 2.828, and 0, negative 2.828. So back there, we'll go 2.8, okay? So there's my ellipse, and then I need to find my foci. So that's b squared plus c squared equals a squared. So b squared we know is 2 square root of 2 squared plus c squared equals 4 squared. So that gives me 8 plus c squared equals 16. Well, c squared is 16 minus 8, which is 8. So the square root of c squared equals the square root of 8. That means c equals 2 square root of 2. So that means my foci points are 2 square root 2, 0, and negative 2 square root 2. Example 3, write the equation of an ellipse. How can you write the equation of an ellipse? What is the equation of an ellipse centered at the origin that has a horizontal axis 10 units long and a vertical axis 16 units long? So horizontal axis, a horizontal axis is 10 units long. In order to find the distance from the co-vertex to the center, divide the axis in half. The co-vertices are each 10 divided by 2, or 5 units from the center, so B equals 5. My vertical axis is 16 units long, so 16 divided by 2 is 8, so A equals 8. The equation represents the ellipse, is x squared over 5 squared plus y squared over 8 squared equals 1, or x squared over 25 plus y squared over 64 equals 1. Okay. B, what is the equation of an ellipse with foci at negative 3, 0, and 3, 0, and that passes through the points 0, negative 4, and 0, 4? The foci are each 3 units from the center on the horizontal axis, so C equals 3, and the center is the origin. The points 0, negative 4, and 0, 4 are on the vertical axis, so they are the co-vertices, and B equals 4. Solve for A, the distance between each vertex and the center along the major axis. So A squared equals B squared plus C squared. A squared equals 4 squared plus 3 squared. 4 squared is 16, 3 squared is 9, so 16 plus 9 is 25, so square root of 25 is 5. So the equation of the ellipse is x squared over 25 plus y squared over 16 equals 1. All right, let's try. What is the equation of ellipse with the foci at 0, negative 12, and 0, 12, and that passes through the points negative 5, 0, and 5, 0? All right, so I have a squared equals b squared plus c squared. So a squared equals b squared is going to be, passes through that point. So that's going to be 5 squared. And then c squared is my foci, so that's 12 squared. So that gives me a squared equals 25 plus 144. So a squared equals 169. So a equals 13. So that tells me that x squared divided by 5 squared plus y squared, which is divided by 13 squared, 1, which is really like saying x squared over 25 plus y squared over 169 equals 1. All right, letter B, what is the equation of an ellipse centered at the origin if the sum of the distances to the foci from any point is 30 units and the vertical minor axis is 24 units long? So the first thing I need to do is actually, because they've given me the entire distance, I need to half that because I'm assuming that it's centered at the origin. Actually, it tells me that. So 30 divided by 2 equals 15, and then 24 divided by 2 equals 12. Okay, so 15 is going to be my A and 12 is going to be my B. So 15 equals A, 12 equals B. So then I have x squared divided by 15 squared equals y squared divided by 12 squared. That's supposed to be a plus, not an equal sign. And that equals 1, where it simplifies to x squared divided by 225 plus y squared over 144 equals 1. Example 4, use an ellipse to model a real-world situation. A whispering gallery is an elliptical room where a soft sound at one focus in the room can be heard clearly at the other focus. A museum has a whispering gallery that is 40 feet on its longest axis, with foci 20 feet apart. The doors are located at the co-vertices. Find the equation of the ellipse representing the shape of the room. How far are the doors from the center of the room? I can formulate. Put the center of the ellipse at the origin with its foci at the x-axis. The vertices are each 20 feet from the center, so A equals 20. And since the longest axis is 40 feet. The foci are each 10 feet, C equals 10, from the center since they are 20 feet apart. I can then compute by finding B squared. Write an equation to represent the shape of the room and determine the co-vertices. So B squared plus C squared equals A squared. You do not need to consider B equals negative 10 square root of 3 as a solution, since B is a distance, which is always positive. B squared plus 10 squared equals 20 squared, so 400 minus 100 is 300, which square root of that is 10 square root of 3. The equation representing the model room is x squared over 400 plus y squared over 300 equals 1. The co-vertices are located at 0 plus or minus 10 square root of 3, so the doors are about 17.3 feet from the center of the room. All right, let's try it. Consider an elliptical whispering gallery like the example, but 30 meters east to west and 34 meters north to south. Find the equation of an ellipse representing the shape of the room. How far are the whispering points from the center of the room? So I have 34 as my longest. It's again centered at the origin. So 34 divided by 2 is 17. 34 over 2 equals 17. Okay, and then 30 divided by 2 is 15. So that gives me my 2 points. So that means my equation is x squared over 225, which is 15 squared, plus y squared over 17 squared, or 289, which equals 1. So the whispering points are about 8 meters from the center of the room. And of course, you can do A squared equals B squared plus C squared and solve for C squared, so C will equal approximately 8. Example 5, graph a translated ellipse. The equation 2x squared minus 12x plus y squared minus 2y plus 15 equals 0 represents an ellipse. Graph the ellipse. What are its key features? So I can write this ellipse in standard form. So I basically get all my x's together, all my y's together, I complete the square, and then that actually gives me my points. So group the variable terms and constants to use completing the square to rewrite the equation with perfect square factors. So 2x squared minus 12x plus y squared minus 2y plus 15 equals 0. I move the 15 to the other side, that gives me negative 15. I factor out a 2 with my x's, which gives me x squared minus 6x and y squared minus 2y equals negative 15. Now I'm going to take the perfect square. Remember that you divide this middle one by 2 and then square it. So 6 divided by 2 is 3, 3 squared is 9. So I have this 2 out front, so I need to make sure that I have 2 times 9 on the other side as well. Then I have 2 divided by 2 is 1, 1 squared is 1, so plus 1, plus 1. So that gives me 2 times x minus 3 squared plus y minus 1 squared equals 4. I divide both sides by 4, which gives me x minus 3 squared over 2 plus y minus 1 squared over 4 equals 1. The ellipse with the equation x minus 3 squared over 2 plus y minus 1 squared over 4 equals 1 is an ellipse with a vertical axis that is a translation of the graph of x squared over 2 plus y squared over 4 equals 1. The center is translated 3 units right and 1 unit up. So 3 units right, 1 unit up. I can draw the axes. The major axis is vertical since 4 is greater than 2. Since a equals 2, the vertices are 3, negative 1, and 3, 3. The minor axis is horizontal and b equals the square root of 2. So the co-vertices are 3 plus or minus the square root of 2, 1, or about 4.41 and 1.61. Then I can find the foci. B squared plus c squared equals a squared. So c squared equals a squared minus b squared. Remember, a is 2 and b is the square root of 2 squared. So that gives me c squared equals 4 minus 2, which equals 2. So c is the square root of 2. The foci are each square root of 2 units from the center of the major axis. Their coordinates are 3, 1 plus or minus square root of 2, or 3 and 2.4, and 3 and negative 0.4. All right, let's try it. Graph the ellipse represented by 10x squared plus 40x plus 2y squared plus 30 equals 0. List the coordinates of the center, vertices, co-vertices, and foci. Drag the points to set the center and axis of the ellipse. So I'm going to first make sure it looks like they're all good. So I'm going to factor out a 10. So I have x squared plus 4 plus, and I'm going to factor out 2. I'm going to move this 30 to the other side. So minus 30. Okay, so now I'm going to complete the square. So I have 10 times x squared plus, oh, that's 4x. Do it again. X plus 4x divided by 2 is 4 plus 2 times, just go through that as is, equals negative 30 plus 10 times 4. Okay, so that gives me 10x plus 2 squared plus 2y squared equals negative 30 plus 40. So negative 30 plus 40 is 10. I divide both sides by 10, so I get x plus 2 squared over all this. X 2 squared over 1 plus y squared over 5 equals 1. Okay, so that tells me that I'm moving 2 units to the left. So move 2 to the left. So negative 2. Okay, my points then are 1, negative 1. Okay, and then negative 2 out there. It's 5, it's 25. So square root of 5. And square root of 5 is approximately 2.23. Okay. Yeah, so negative 1, negative 3. Okay. All right, and then my foci are at negative 2, 2. Oops. Negative 2. So center is at negative 2, 0. Vertices are at negative 2, square root of 5, and negative 2, negative square root of 5. Co-vertices are negative 3, 0, and negative 1, 0. And the foci are at negative 2, 2, negative 2, 2. All right, let's try it. Graph the ellipse represented by x squared plus 3y squared minus 8x plus 6y plus 10 equals 0. So first thing I want to do is I want to group my same values together. Y squared plus 6y. I'm going to move that 10 to the other side. Okay, so I have 8x, x squared minus 8x plus, I'm going to take that 3 out, y squared plus 2y equals negative 10. Okay, I complete the square. So x squared, negative 8 divided by 2 is negative 4, squared is 16. So minus 8x plus 16 plus 3 times y squared. 2 divided by 2 is 1. 1 squared is 1 plus 1 equals negative 10 plus 16 plus 3 times 1. Okay. So that gives me x plus 4 minus 4 squared plus 3 times y plus 1 squared equals 9. Divide both sides by 9, so I get x minus 4 squared divided by 9 plus y plus 1 squared divided by 3 divided by 9 simplifies to 1 over 3 equals 1. Okay, so that means my Center is at, so this means it moved over 4 to the right and up 1. Okay, so my center is at 4, -1. Okay, square root of 3. So that's going to be 4 and -2, 7, roughly. Okay, and then 1, -1. Right there. Okay, so that means my major vertices are at 1, -1, and 7, -1. Oops. So 4, -1 is my center. Vertices are 1, -1, and 7, -1. And co-vertices are 4, -1 minus the square root of 3, and 4, -1 plus the square root of 3. And then my foci are at 4 minus the square root of 6 minus 1, and 4 plus the square root of 6 minus 1. Concept summary. Ellipses. Definition. An ellipse is the set of points P in a plane such that the sum of the distances from P, X, Y to two fixed points F sub 1 and F sub 2 is a constant. So I have two graphs. I have a horizontal, which is my major axis, and then my vertical is my minor axis. Or I have a vertical as my major and a horizontal as my minor. Okay, so whichever one is the major, that's your A. Whichever one is your minor, that's your B. So whether it's horizontal or vertical. Okay. So I have two equations. If my horizontal is my major, it's x minus h squared over a squared plus y minus k squared over b squared equals 1. If my vertical is my major, I have x minus h squared over b squared plus h or y minus k squared over a squared equals 1. If the major axis is horizontal, h plus or minus a, k are the vertices, and h, k plus or minus b are the co-vertices, and h plus or minus c, k are the foci, where a squared equals c squared plus b squared. If the major axis is vertical, h, comma, k plus or minus a are the vertices, h plus or minus b, comma, k are the co-vertices, and h, comma, k plus or minus c are the foci, where a squared equals c squared plus b squared. And that is the end of Unit 9, Lesson 3.